Welcome back from the ad break, and let's continue with our lesson. So now we are going to focus more on those application questions. Let's look at our first question. So it says they fill in the following flow diagram. Now remember, our flow diagram has input values and they go through the rule and then they give us the output value. So let's look at what the rule is here. So the rule says y is equals to 2x plus 5. Now what does this mean? It means that for us to get the output value, we need to multiply the input value by 2 and then add 5. And that's how we are going to get our output value, which is our y. So let's do that. Now, our first input value is a 3. So we are going to take the 3 and we are going to multiply it by 2. And then we are going to add our 5. Now, our 3 multiplied by 2 is 6. When we add 5 to this, this is going to give us an answer of 11. So it means that our first output value there is 11, because 3 times 2 is 6. And when we add 5, it will give us an 11. Let's look at the next input value, and that is our 16. So again, we are going to take the formula or rule that we have been given here. So we need to take our input value, multiply it by 2, and add that 5. Now, 16 multiplied by 2 is, of course, 32, and we are going to add 5 onto that. So 32 plus 5, that is going to give us an answer of 37. So that is our second output value there, if the input value is a 16. Then lastly, we're going to look at that last input value, and that is our 20. So for us to find the answer there, we need to take our 20, multiply it by 2, and add 5. So when we take our 20 multiplied by 2, that will give us a 40. And when we say 40 plus 5, our answer is 45. So that would be our output value when the input value is a 20. So we've used our rule that we were given to find those output values. Now, let's continue to the next question. The next question there says, determine the rule for the following relationship between the input values and the output values. Write the rule as an equation. Now, looking at this table that we have been given here, we are being presented with the input values and the output values. Remember, the input values are the ones that are written at the top of the table, and the output values are the ones that are written at the bottom of the table. So we are going to see or try to determine the rule from these given values. Now, we have been given the first input value being 1, and then that results in 4. And the second value being 2, and that results in a 6, and the third value being 3, and that results in a 14. We are given the fourth input value and the fifth input value as well. Now remember, for us to determine the rule, we need to make sure that the input values or the term numbers are consecutive. You remember when we were working with number patterns, how we would use the first, the second, and the third term just to see what is the difference between the numbers. So now we have been presented with actually consecutive terms, because the first input was a 1, the second input was a 2, and the third input was a 3. So let's see what is the pattern here so that we can determine our rule for our input values and our output values. So there we have a 4, and after a 4, from the 4 to move on to the next number, we have been given, that is, we add 5. Then from the 9 to the next number, which is 14, again, we add 5. And we can see there is a pattern here, but you should keep in mind that this pattern only exists because these are consecutive terms. And if you remember what consecutive terms are, these are terms that follow each other in a pattern. So we need to make sure that when we want to determine the rule from a table, that those numbers must be consecutive numbers. So we are going to find this rule. Now remember, the input value is represented by an X and the output value is represented by a Y. So the same as we did with the number patterns, we are going to find the output value. And how are we going to find the output value? By taking that constant difference that we are seeing there, which is going to be our 5, and we are going to multiply this by the input value, which in this case, we are using actually our X. And again, we are still going to add or subtract a constant just so that we can see what the pattern is. Now, you can take any input value here as long as you use the corresponding output value. So we are going to take the output value of 19. So if we use 19 and we say 5 multiplied by 4. Why are we using 4? Because for us to get 19 as an output value, we used 4 as an input value. So when we say 5 multiplied by 4, that gives us 20. Now how are we going to get to 19? Of course, we are going to subtract that 1. Now let's use another term to check if perhaps we are correct with that constant of minus 1. Now let's take the fifth term. So the fifth term, or the output that uses 5 as an input there, that is 24. Now that 24, remember, comes from us using 5 as an input. So that means we're going to say the 5 that was the constant difference there, and we are going to multiply it with the input value, which was a 5 as well. Now 5 multiplied by 5, that gives us a 25. And of course, how do we get to 24 from 25? We are going to subtract 1. So what are we seeing here with our rule? We can see that for us to get the output value, we are going to take this constant difference that we have seen between these consecutive numbers, or between these consecutive inputs. We are going to take the 5 and we are going to multiply it by the input, and we are going to subtract 1. So this is going to be y is equals to 5x minus 1, and that is going to be the rule of our table there, or basically the relationship between the input values and the output values. So how do we get the output values? We multiply the input value by 5 and then we subtract 1. Let's move on to our next question. So our next question there says, find the missing part of the rule in the flow diagram. So when we look at this flow diagram, we have been given the input values and the output values. So nothing is missing there. We have all those numbers. Then we have only been given the second part of our rule there, and that is 2 minus 2. Remember that there is our rule, but our rule is clearly shown to having 2 parts. So the second part, we know that we are going to subtract by 2, but how are we going to find the first part of our rule? Now let's look at the input values and the output values. Remember, they have a relationship. Now we know that the first part of our rule applied to 1, and then from the result we did subtract 2, and then we got an answer of 7. So for us to be able to get what the rule was, we need to move backwards, or we need to use the additive inverse of negative 2. Now the additive inverse of negative 2 is a positive 2. That is the additive inverse of a negative 2. So what are we going to do? We are going to take the 7, we are going to move backwards and add 2 to that 7. So when we say 7 plus 2, that will give us a 9. Now from that 9, we need to figure out what happened from 1 to 9. Now there are a couple of options, of course. We can say that we added 8, but we can also say that we multiplied by 9. So because we are not sure, let's use the second input and output value to see what those options are. So it's either we added 8 or we multiplied by 9. Now one of them has to work for all of these input and output values. So let's take 61. Now when we take 61 and we use the additive inverse of negative 2, we are going to add 2 to 61. Now that is going to give us a 63. Now from 7, will we get 63 by adding 8? Absolutely not. Will we get 63 by multiplying by 8? Yes, that is correct. Sorry, by multiplying by 9. So from 7, when we multiply by 9, we do get that 63. But let's check with our first input and output value if it works. 1 multiplied by 9 also gives us that 9 that we found there. So just to be extra sure, let's see if it also works with the last input and output values. So we have been given there a 97, and we are going to apply the additive inverse of minus 2 by adding 2. So 97 plus 2 gives us 99. Now 11 multiplied by 9, do we get that 99? Yes, we do get that 99. So it means that that missing part of our equation is not, or that missing part of our rule is not a plus 8, but it is a multiply by 9, as it applies correctly to all of these input values and the output values. Let's look at the last question that we have been given here, and this is just to write down the output values and represent the rule as an equation. So we have been given variables as the input values, and we are supposed to now write down the output values for starters, and then we are going to write down this rule as an equation or in an algebraic form. So the first input value that we have been given is A. So we are going to take that A, we are going to divide it by 3, and we are going to add 10. Now, because this input value is a variable, we cannot simplify that further. So we are just going to leave it as A divided by 3 plus 10, which is exactly what our rule is asking for. Let's look at the next input value, and that is a B, also a variable. So we are going to take our B, and we are going to divide that B by 3, and we are going to add our 10. So B divided by 3 plus 10, that is what our output is going to be. What about this last input value here? We have our C, and we are dividing that by 3, and we are going to add 10. So that would be the output value there. And for the last part of our a question there, to write the rule as an equation or in an algebraic form, we are going to say we get the output value by taking the input value and dividing it by 3, and then we are going to add our 10. So there we have represented it using the variables that are used for our input value and our output values. Let's quickly go to an ad break, and then we'll see you just now.